everyone. Good morning. We are Team 4, CHOPtimization. My name is Shayna, and along with me is Hannah and Rosie. So this year, we've been working with CHOP to help them create an algorithm to predict wait time for patients. So a few facts about CHOP. They are the Children's Hospital of Philadelphia, and they are the #2 children's hospital in the U.S. Over 1 million patients are seen annually, both in the emergency department and in the inpatient units. There are 540 beds in the hospital, and additionally, 25% of patients that are seen in the ER are eventually admitted into the inpatient units. And this is the process that we'll be focusing on. So the way this process works right now is that patients are deemed medically ready for transfer if they need additional treatment after being seen in the ER. Then a nurse in the ER goes ahead and assigns them a bed in the corresponding inpatient unit. And from there, the nurse in that inpatient unit approves the bed. From there, the conversation between the nurses and the doctors can begin. After all information has been transferred, the handoff is complete. And finally, when the patient is in the inpatient unit, they are admitted into the hospital. So right now, this process occurs within 2 hours for only 50% of patients. So that means that half of the patients that get into the hospital have to wait over 2 hours for this to happen. And CHOP has set a goal for all patients to be admitted within 2 hours. And in our project, we aim to help them in this goal. And we aim to do this, or we did this in 2 ways. The first is to predict the wait time. So we created an algorithm that Hannah will detail out that estimates the wait time for each patient based on a number of factors. And this is useful in 2 ways. One, the nurses will have access to this information in order to better plan the process that I've just detailed out. And secondly, they'll have this information in order to give to the parents and the families of the children in order to improve the patient experience. Secondly, we've digitized this process for nurses. So the algorithm that we've created is hosted on a website that can be used both on a desktop and a mobile device. And this is useful for the nurses so that they are able to see and update the process of patients no matter where in the hospital they are. So now I'll turn it over to Hannah to talk a little bit more about the algorithm and detail that out.
Great, thanks Shayna. So over the course of the year, we considered many alternate designs in terms of developing our algorithm and also our overall project. So first, we used linear regression to model our data. However, found this wasn't actually the most accurate way to do this. It wasn't just that accurate in terms of predictive versus actual results. So we decided to use more advanced statistical tools. We also, at first, implemented our project using a macro on Excel using VBA. However, not surprisingly, this wasn't that robust. It wasn't that useful for the nurses. It was a little bit bulky as far as software goes. So we decided to implement our interface on a website after considering a mobile app. We decided that a website was more applicable for the nurses, a little bit more useful. CHOP has a lot of desktop computers lying around and just everywhere in the hospital. And also our website, since it can be used on mobile devices, it basically did everything that an app could do, plus more. So our model uses 5 different inputs to correspond to 8 covariates. So we use time of day, day of the week, and month of the year as inputs to our model. Since these 3 factors are all circular and continuous, we had to take the sine and cosine of them, which then made these 3 inputs correspond to 6 different covariates. We also use time since or until the next nurse's shift change. So nurses change shifts around 7 a.m. and 7 p.m. Around these times in the hospital, the nurses are all talking. The nurse either coming before or after them. Because the hospital is very hectic, they're not taking care of patients as much as they could be around like 1 a.m. or 1 p.m. So the closer a patient is to coming in at 7 a.m. or 7 p.m., the longer this process takes overall. Lastly, we consider census of the hospital. So census indicates how busy the hospital is. We implemented this using a binary variable, 0 or 1, where 1 indicates a busy hospital day, high, and 0 indicates low or a low busyness day for the hospital. And we implemented this using a Weibull distribution, which is an expansion of the exponential, which adds one more parameter, in our case C, which takes into account time dependence. So we model about 85% of our data chosen randomly with this Weibull distribution. We set each individual step to this distribution and found the optimal value of C and lambda for each individual step, also taking into account each individual patient's covariates. We then fit this data to the remaining 15% of our data, randomly segmented out, and use the expected value patient on the second line to find the expected wait time for each individual patient. We found these results when looking at the summation of all 4 steps in our process. So you can see that our predicted time is over our actual time, which is actually good for 2 reasons. First of all, it's a better way for us to err on the side of. So it allows the nurses a little more wiggle room, a little more buffer in the hospital to take care of their patients, especially as they adapt to using this new software. Additionally, our algorithm doesn't take into account if patient suddenly becomes critical, because the hospital doesn't know that, we don't know that in our algorithm. So our algorithm can't take into account if patient suddenly becomes critical, and therefore will move through the process almost instantly. So this is more for patients who aren't critical and don't require urgent care. So now that I've covered the algorithm, we're just going to discuss how we implemented it in our website.
Thanks, Hannah. Now, here's an image of what our website currently looks like. And our main goal of creating this website was to create one that was really user-friendly and one that would be really easy for the nurses to understand. Now, when a patient is deemed medically ready for transfer, the nurse logs on to the website and will input the patient's name, date of birth, the inpatient unit in which they're being transferred to, and the current census of the hospital. Then using the back-end algorithm that Hannah just talked about, we'll output a predicted wait time, which is shown on the right-hand side of the screen. Now, as a patient moves through the 5 different steps of the process, the nurse can easily click on the patient's name and put the process that they're current, or the stage that they're currently in, and that will also update the predicted wait time until transfer. As soon as a patient is admitted into the inpatient unit, their row will be highlighted in green as shown on the first name, and then their estimated wait time is now 0. The nurse now has the option to delete the patient from the database using the red box, and this process will continue for all of the patients that are in the hospital. Now, we wanted to do a lot of user testing with the nurses to ensure that our website was up to par and up to the standards that they were looking for. So we tested our website against 5 different factors to ensure this, and these are learnability, efficiency, memorability, errors, and satisfaction. And now what this really means is that we wanted our website to be really easy for the nurses to learn and to understand how it works. It was really quick and easy for them to use and wasn't taking away from their daily activities. We wanted them to be able to really remember how to use the website, so throughout the middle of the day they wouldn't have to go back and remember. We also wanted to make sure there were no errors in our website and no glitches in it. And finally, we wanted to make sure that they were overall satisfied with the product, and this is really what they wanted. Now on the right-hand side of the screen is the input page for the nurses, and that's what they fill out when a patient comes in. And as you can see, we really kept the inputs to a low amount, so this would be quick and easy for the nurses and really wouldn't take up much time. Now as we head towards graduation, we're going to continue working with CHOP to ensure the success of our project, and we're going to do this in 2 different ways. Now our first goal is to integrate our back-end algorithm with Epic, which is the current system that the hospital uses, and this would really streamline the process for nurses. However, because of security clearance, we weren't allowed to do it ourselves, so we're handing over the algorithm and the website to them to make this a lot easier, and since the patient's name and date of birth and that information would already be in there, it would really just output the estimated wait time for the nurses. And now second of all, we're going to continue training the nurses on the importance of our algorithm and how to use the website, because we really want to make sure that once we hand it over, they'll know exactly how to use it and can train future nurses that come on board. And with that, we'd like to thank you all for being here today, and we look forward to seeing you all later today. Thank you.